Hey everyone, and welcome. Today, we're going to pull back the curtain on a hidden pattern that shapes so much of our world, from how your salary might grow to the way a garden is planted. It's a really simple, predictable rule that once you see it, you'll start spotting it everywhere.
All right, to get us started, think of this like a little puzzle. I'm going to show you three totally different situations. Your mission, should you choose to accept it, is to find the one simple rule that connects them all. You ready?
First up, let's talk about a job offer. A woman named Rena starts a job with a salary of $8,000, and she's guaranteed a 500 raise every single year. Nice and steady, right? A predictable increase.
Okay, next, picture a ladder. The very bottom rung is 45 centimeters long, but as you go up, each rung is exactly 2 centimeters shorter than the one right below it.
And for our final clue, let's look at a flower bed. The first row has 23 beautiful rose plants. The second has 21, the third has 19, and you can see each row is getting smaller by a very consistent amount.
So, did you spot it? We've got a salary that's growing, a ladder that's shrinking, and rows of roses that are disappearing. What's the single hidden rule that's driving all three of these patterns?
If you guess that every step in the pattern involves adding or subtracting the exact same number, you absolutely nailed it. This powerful little pattern has a name, so let's get formally introduced.
The secret really is that simple. With the salary, you just keep adding 500. For the ladder, you're adding -2 each time. Same at the roses, you're adding -2. It all comes down to that constant, repeated step.
So, this powerful pattern is officially called an arithmetic progression, or AP for short. It's just a list of numbers where you get the next number by adding a fixed amount to the one before it. And that fixed amount, we call that the common difference.
What's really cool is that any AP is built from just two key ingredients. You need a first term, we call that A, which is basically your starting point, and you need the common difference, we call that D, which is the fixed step you take every single time. That's it.
Now, to make this super clear, let's compare our salary example with a different kind of growth. The salary is an AP because we add a fixed amount. But look at the savings scheme. It grows by multiplying by a fixed amount. See the difference? That's a whole other kind of pattern, a different beast entirely.
Okay, so now that we can spot an AP in the wild, let's unlock its first superpower, the ability to see into the future of the pattern without having to trudge through every single step to get there.
Let's go back to Rena's salary. Say we want to know what she'll be making in her 15th year on the job. I mean, we could sit here with a calculator and hit plus 514 times, but surely there's a shortcut, right?
Of course there is, and we can build it together. Just look. To get to year 3's salary, you start with 8,000 and you add 500 2 times. So for year 15, you'd start with 8,000 and add 500, 14 times. You see the pattern? The number of times you add the difference is always one less than the term number you're trying to find.
And that simple little observation gives us this incredibly powerful formula. With this equation right here, you can instantly jump to any point in the sequence you want. The 15th term, the 15,000th term, doesn't matter. You just plug in the numbers. It's like a predictive toolkit.
All right, predicting a single term down the line is pretty awesome, but what if you want to know the total of everything up to that point? Like, what's the total amount of money Rena earned over all 15 years? Now that's a really important question, and it requires the AP's second superpower.
And this actually leads us to a famous story about a young math genius named Carl Friedrich Gauss. His teacher, probably just to keep him quiet for a while, gave him a task that seemed like it would take ages. Add up all the numbers from 1 all the way to 100.
So Gauss did what anyone would do. He just wrote down the problem. He called the sum S for, well, sum.
But then he did something absolutely brilliant. Right underneath that first line, he wrote the exact same list of numbers, but completely backwards. And here's where the magic happens. When you add those two lines together, vertically, every single pair adds up to the exact same number. 1 plus 100 is 101. 2 plus 99 is 101, all the way down the line. He realized he had 100 pairs that all equaled 101.
So he knew that double the sum was just 100 times 101. He did a quick division by 2 in his head, and boom, he got the answer, 50-50, probably blowing his teacher's mind in the process.
What's so incredible is that Gauss's little trick can be turned into a general formula for the sum of any arithmetic progression. Take a look. This gives us a way to find the total of a huge series of numbers in one clean move, without having to add them up one by one.
So we can find any term, we can find the total sum, but why does this really matter? Because this simple pattern of steady change is a fundamental model for how so many things grow and shrink in the real world around us.
Yeah, this isn't just some abstract math concept. This is the tool you'd use to calculate total loan repayments, to model factory production, to figure out how many seats are in a triangular section of a stadium. It is the basic language of steady linear change.
So the next time you see something that's changing by the same amount, step by step, you'll know exactly what's going on under the hood. And that kind of brings us to our final thought. Now that you know the rules, what predictable pattern in your own life could you start to calculate?